Hi and welcome to this tutorial on the canvas and canvas scaler components in Unity. My name is Christina and I'll explain how to choose the right canvas rendering mode for your game, how to handle different screen resolutions, why rendering modes matter in the first place, how each mode has its own special use cases, and how to optimize your UI. By the end of this tutorial, you'll understand the differences between ScreenSpace Overlay, ScreenSpace Camera, and WorldSpace modes, and how to use the canvas scaler to ensure your UI looks great on any screen resolution. So, what is a canvas anyway? It is a component in Unity that acts as a container for all UI elements. It gets automatically added to your scene if you create any kind of UI element, but you can also just create a simple canvas on its own from the menu. I like doing it that way, because if I start straight with an image or text, it's super easy to forget setting up the canvas itself. Each canvas comes with 4 different components already attached: Rect Transform, Canvas, Canvas Scaler, and Graphics Raycaster. Rect Transform will give you options as to where to place your canvas in case of World Canvas mode, more on that in the World Canvas chapter. The Canvas component manages the rendering order and display of UI elements. Canvas Scaler lets you set up how your UI should behave on different resolutions, and the Graphics Raycaster handles if clicks on the UI should be registered, which might not always be the case. We will have a look at an example in a moment. So, working with multiple canvas objects. You probably already built a UI on your own and stored every element and window in a single canvas element. I know I have when I started out. But there are quite a few reasons why dividing up a complex UI has its benefits. Mostly because it's easier to sort and layer elements, but especially with complex UIs, it offers a way to optimize for performance. This won't be too important if your game only has a simple UI element like a coin counter or a heart counter, perhaps with a pause menu. However, as soon as you start adding more interactive elements, such as multiple windows, intricate inventory or shop systems, or just generally heaps of elements that change upon interaction, there are benefits in dividing one canvas into multiples. My personal reason for dividing up UIs into separate canvases is that it makes handling and modularizing UI so much easier to use to me. But also, whenever something on your UI changes, even if that change is just your character avatar blinking, the entire UI gets rebuilt. By using multiple canvases, you can separate never-changing elements from dynamic ones. This way, only the relevant canvas is redrawn, reducing the amount of redrawing needed and improving performance that way. But if you ever wonder what eats performance in your project and if in fact it's the UI, I highly recommend you learn how to use the Unity Profiler. You'll find a link to a very good explanation in the video's description. Don't just fall into a performance optimization frenzy if what you try to optimize has nearly no bearing on your game's performance. So, how could and would I divide up this UI? First, I create additional canvases for each logical group. For example, one for the pause window, one for the dialog window. I rename the canvas for the main UI to reflect its contents. I typically keep the canvas name for those game objects to make finding elements easier. My constantly visible game UI with avatar, health and action bar is hardly complex enough to be able to gain any meaningful performance boosts when divided up, but I will put the purely decorative elements on their own canvas anyway, because if you have a purely decorative canvas, consider disabling its Graphics Raycaster component. This allows clicks to pass through it, so your game doesn't need to check if the UI is being interacted with unnecessarily. There are situations in a game in which we might not want to allow for camera or character movement, for example. The pointer being above a UI element can be such a situation. For example, I don't want the player to be able to zoom the camera when over UI, because my UI might need a scroll wheel for a scrollable text box. Or I just don't want to look around while navigating inside my inventory. You can check for UI elements at your pointer's location by using this line of code. Event system current is pointer over game object. Just make sure you have an event system in your scene. It should already be created automatically when you've created your first canvas. If it's not there, you can get one by right-clicking in the hierarchy and choosing Event System. Now, since all of our background art sits on its own canvas and we probably want to ignore it when checking for UI, we can just remove that canvas's raycast component. This way, isPointerOverGameObject will return false, since the UI isn't being detected as such anymore. Sorting orders. You get 3 different rendering modes: ScreenSpace Overlay, ScreenSpace Camera, and WorldSpace, and each one comes with sorting orders. Because these relate to a key workflow of working with canvases, let's tackle these next. With sorting orders, you can get more control about which order things get rendered at. This can be useful if you are using multiple windows that should overlap each other, for example. Or maybe using this sorting order just makes more sense to you than switching positions inside a hierarchy. I have a current long-term project in which I used this sorting order a lot to not accidentally move a canvas around and suddenly break the way my menus get displayed, for example. ScreenSpace Overlay. Alright, now that our UI is divided up, let's have a look at the different modes. We are going to go through canvas scaling afterwards. ScreenSpace Overlay is the default one. It means that whatever you put on this canvas gets overlaid on top whatever the camera sees and renders. A typical use case for this mode is your game's UI like action bars, inventories and the like. This might sound trivial, but it actually has consequences. If I move the camera, the UI stays in place at all times and it won't be affected by anything going on in the scene. No lights, no particles, no post-processing effects. So if you want or need particles or other effects, you might want to use ScreenSpace Camera mode instead. The checkmark for Pixel Perfect is only available in ScreenSpace modes and toggles anti-aliasing on and off for your UI. The next entry is kinda niche and about which display the canvas should render on. So if your project is going to be displayed on multiple displays, you can tell Unity on which of the displays your canvas should show up. Have you ever used this? I'd love to know. In case you use special UI shaders, you might have to check if all your needed shaders are listed in this dropdown. Shaders aren't my strength, so I typically keep that at its default setup. The last toggle for this canvas setup concerns keeping the color space in gamma color space. Built-in shaders in Unity typically handle gamma to linear conversion automatically, so this setting is, again, mainly relevant for custom UI shaders. In this project, menus, action bars, and general player information are sitting in a ScreenSpace overlay canvas because I want those to sit on the same position at every moment and they don't need any particle effects. ScreenSpace Camera. Next up is ScreenSpace Camera. As long as you don't specify a camera, it behaves just like ScreenSpace Overlay. With place distance, we can now actually position the canvas on the Z-axis relative to the camera, and the canvas will always be rendered inside the viewport of the player. So if I move the camera, the canvas will move right along with it. But it might be rendered behind elements in the scene, which can be quite a cool effect, honestly. Here I have a scene set up for my game's main menu, with a witch, some spells, and some architecture. By changing the distance of the canvas to the camera, I can position it behind the action, giving it a much more lively first impression of my game. Two things get unlocked once you set your canvas to ScreenSpace canvas or world canvas in a moment: post-processing effects and particles. So if I use a post-processing volume with a bloom effect and enable post-processing in my camera, my UI will now also be affected by that. Likewise, if I want to have particle effects either through VFX graph or particle system, those will only show up if the canvas is set up for ScreenSpace Camera. If you need your canvas to be in overlay mode but still want particles, I highly recommend the UI particle asset from the asset store. It solves that issue and is super enjoyable to work with, especially compared with the particle effect system, which does not scale with UI scaling and thus just isn't readable on high resolutions anymore. Even if you don't care about any post-processing or particle effects, I highly recommend setting your UI to ScreenSpace in case you want to take screenshots without the UI getting in the way. There are a lot of ways to grab a screenshot. Here are just two simple ones. This one works well enough if you're fine with the UI showing up and can be used if your UI is set to overlay too. But in case you want to hide the UI, or any other specific layer really, for the screenshot, you need to remove the UI layer from the camera's culling mask. Remember that in overlay the camera doesn't see the UI and that it just gets overlaid on top? That is why removing it from what the camera sees doesn't work if it's set to overlay. It's not being seen by the camera by default, so we can't disable the layer like that. But if you switch over to using ScreenSpace camera, the UI is part of what the camera sees, so by removing it from the culling mask for a frame and taking a screenshot, it won't show up in the resulting image. Yes, you could just disable the canvas for a frame when taking the photo and that way hide it in overlay mode as well. But hiding things from the camera does not trigger any on-enable, on-disable and other behaviors you might have set up when things get set to inactive, which is why I prefer this way of getting to my goal. The last entry in this list is a world space canvas. You'll want to use this whenever you want a canvas to be unlinked from your camera. For example, when creating pop-ups and menus which should behave as if they were in a 3D room, when your game has the player interacting with monitors of some sort, or even for just chat bubbles or signage. As you can see, once you set the render mode to this, you get access to the rect transform values, which hadn't been possible before. As with the ScreenSpace camera set canvas, you get access to post-processing and particles in this mode. If you ever tried using the world space canvas before, you probably ran into the problem of numbers not making a whole lot of sense anymore. For example, if I create a pop-up for a location, the text will still be huge. To make it look decent, you probably started to scale down the text to fun numbers like 0.23 or the like, or treat boxes similarly. I know I have in the past, and it infuriated me. So, let's have a look at how to tackle this from the other direction. How does world space actually work before we set any other values? Overlay mode and world canvas share that they are initially ridiculously looking in size. So let's see what we need to get to a more manageable version to work with. This is a standard cube in Unity. It is 1 unit big. I want a canvas element to be equal in size as well. I set the canvas to world space and fill it with some background image. By holding Alt and Shift, the image will automatically stretch to the size of the canvas. More on anchors and placement in my anchors video. I now set the width and height to 100 pixel and the scale of the canvas to 0.01, a hundredth of its original scale. Both the cube and the UI are now of the same size, and I can still work with the numbers, scales and font sizes inside the canvas as if it wasn't shrunken down that much. So let's give 2 use cases a try. First, I want to have an info box for an item in my game world. I scale my canvas to the size I want the pop-up to have, place it above the item and fill it with some random info to show about the item. This is now just sitting at the position, which doesn't really look all that intentional. I want the canvas to always look at the player, so reading is easy. We can get that functionality with just a simple line of code. In Update, we tell the transform to look at the main camera, which is called Billboarding. That's going to be the standard camera that comes with any scene. If you got rid of it, you will have to tag your camera with the main camera tag like this. Alternatively, you can declare the camera you want to use. When we now get back into the scene, the box will always rotate so that it looks at the main camera. For the signage, I created a very simple wannabe wooden base so that the typography looks more at home in my 3D world. You can get this model on my Discord server if you want. I create a new object, place the empty sign in it, create a world space canvas, give it the intended width and height, and scale that down to 0.01. Then I fill it with whatever info I need and I prefab it. I can now reuse this sign every time I need to label stuff. Neat. And hey, if you have learned something new, please give my tutorial a like. And if you'd like to get more tutorials on topics like this, click on subscribe. So much about the 3 rendering methods. Let's tackle the canvas scaler next. As long as you are using any of the ScreenSpace modes, you'll have access to the canvas scaler. In it you can set how you want your UI to behave and look on different resolutions. If you haven't seen my tutorials on working with anchors, I highly recommend doing so, as some of the behavior we will see depends on understanding anchors and being able to set them correctly. This component handles how your UI will be displayed on different resolutions, and you might wonder which resolutions you need for your game. For consoles, those are rather straightforward to look up, I guess. But for PC, you can access the Steam Hard and Software survey. Again, the link is in the video description. If we click on the primary display resolution, we can see that the vast majority of players use 1920 by 1080, followed by 2560 by 1440. I highly recommend to focus on these two resolutions when creating your UI, as all the others are niche in comparison. Also, you can filter this list of settings to display Windows, Mac and Linux, or just focus on one. If you only plan to create your project for Mac, your choice of basic resolutions and supported other resolutions might look quite different to a project for Windows exclusively. Constant pixel size is just that. All the elements on this UI will keep their respective sizes and positions. Let's have a look at the action bar I set up. It's 300 pixel high, but only the top 150 pixel get displayed. The anchor is set to middle center bottom, so it will always stay at the lower edge of the screen, no matter which resolution gets chosen. It is set up in a way that will make sure that the bar will have a gap of 500 pixels to the left and to the right of it. The resolution I display the game at is initially set to 1920 to 1080. When I change the resolution to 2560 to 1440, we see that the lower bar seems to shrink a little in height and expand in both directions. It will still have a visible height of 150 pixels, but based on the stretch setting I set in its anchor, it will expand until it again leaves a gap of 500 pixels to both sides. If I change the resolution to Portrait, 1080 by 1920, the bar will only be 80 pixels wide due to the 500 pixel gaps in both sides. Constant pixel size will leave the values as you set them, but keep in mind that if your players are using higher resolutions, their UI will feel shrunken down, maybe even be hard to read. The reverse is true as well. If the player uses a smaller resolution, your UI might be unintentionally gigantic. Scale factor scales your UI by the number you set into it. And typically, I'd highly recommend keeping it at 1 really. It's an easy thing to overlook when working with UI graphics at a later point. But a case can be made for this to get an entry in the options menu, so the player can scale the UI if needed. That's an accessibility option you might want or have to keep in mind. So, to make sure the UI looks the same but still scales in a way that keeps it reasonably readable on every resolution size, you might want to use Scale with Screensize instead. This will instantly give you a heap of settings to consider, so let's have a look. Reference resolution should be the base resolution you create your game for. In the case of a PC game, we saw in the Steam survey that 1920 by 1080 is the resolution used the most often, so we should use that here. Screen Match Mode gives you options on how the UI should handle resolutions with different aspect ratios from your reference one. We get Expand, Shrink and Match Width or Height. When we pick Match Width or Height, we get asked how it should get handled. Is it more important to scale to width or to height, or something in between? Let's look at an example. If I stay at 1080 or 1440, there is no apparent difference. But when I choose some dramatically other resolution like Portrait mode for a phone, is it more important to fit the whole width of the UI in this other aspect ratio? Or do I need to display the whole height? Or does any value between those extremata work best? If I change to an ultra-wide resolution, the answer might look very different too. If you expect your players to use portrait and horizontal screens, it might be best to just create a base canvas for each of them to make sure no surprises happen and things will still look as expected. Shrink and expand really are just the left and rightmost values as a shorthand. You can see in the scale value on the rect transform how your choices influence the UI scaling as well. The probably most special case when it comes to canvas scaling is constant physical size. We have looked at unit sizes before when creating and scaling the world canvas and dividing its size by 100 to get the same size for a 1 unit big box in the world and in the UI. With constant physical size, we can actually tell our UI what unit this should correspond to: centimeters, inches, points or pica. Keep in mind this is only for the UI. When you set the canvas scaler to this, it uses the screen's DPI or dots per inch to scale the UI elements. The goal is to keep the UI elements' physical size consistent across devices with varying screen densities. Let's use inches for the physical unit as an example so we don't get confused by unit names. DPI means dots or pixel per inch. So when we set this to 9060 Pi, which refers to a PC monitor pixel density, we get 96 pixel per inch on the monitor. This means if we have a graphic that is set to 9060 Pi and it is set to 1 inch by 1 inch in size, it will correctly be displayed as that physical size no matter if you look at it on a high DPI device like a smartphone or your typical desktop monitor, which is still typically around 72 to 96, depending on how old that monitor is and which source you look this value up in. In case your square looks bigger or smaller, make sure you set the scale of your game to 1 in the slider up here. Okay, so let's recap. Optimizing with multiple canvases. Splitting your UI into multiple canvases helps improve performance by only redrawing elements that change rather than the entire UI. Personally, I think it tidies up the UI quite a bit and makes it easier to manage by having each big thing on a UI be its own canvas. Managing sorting orders and disabling unnecessary raycasters can further enhance efficiency, and disabling raycasters for a whole canvas can help in keeping track of why or why not a certain element on a canvas might not behave as expected when clicked. For the canvas rendering modes, ScreenSpace Overlay is ideal for UI elements that should not be affected by in-game effects or camera movements. ScreenSpace Camera provides dynamic UI effects, integrates with camera post-processing and particles, and is useful for more immersive interfaces. WorldSpace allows for UI elements to exist within the game world, and thus is perfect for in-world monitors, speech bubbles, and info boxes. And lastly, about using Canvas Scaler, constant pixel size ensures UI elements maintain their size regardless of resolution, but may lead to readability issues on other screen resolutions than your base one. Scale with screen size adapts the UI to different resolutions while maintaining readability based on a reference resolution. Constant physical size keeps UI elements consistent in physical dimensions across devices with varying screen pixel densities. Oh, and if you enjoyed the models I've been using in this tutorial, they come from Kai Lausberg's really good Dungeon Remastered 3D asset pack. You can grab the free one on itch or pay to get even more models. His assets are really well done and fun to work with. This isn't sponsored, I just really like Kai's assets. I hope you enjoyed this tutorial. If you have any questions or comments, please find your way to the comment section. Have a great week.